Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to support our actuarial students with a tax-deductible donation, you can go to smarturl.it/help-ISU-actuary. This is the last written answer section problem from the Spring 2017 exam MLC. Kira, age 63, is a participant in XYZ's defined benefit pension plan. She was hired at age 35 at a salary of $40,000. Well, it doesn't say dollars, but 40,000. XYZ provides salary increases of 3% at the end of each year of age. You are given the normal retirement benefit payable from age 65 as 2% of the final 12 months salary per year of service. The retirement benefit is payable as a life annuity due with semi-annual payments. For early retirements, the pension benefit is reduced by 0.5% for each month that retirement precedes age 65. Decrements from active employment before age 65 follow the illustrative service table, not life table, sorry, illustrative service table with decrements occurring in the middle of the year. All employees who reach age 65 retire immediately. There are no death benefits. Mortality after retirement follows the illustrative life table with deaths uniformly distributed over each year of age. The interest rate is 6%, which is the rate used in the illustrative life table, and that's something always to make sure. For a retired employee, A double dot upper 2 63.5 is 10.0282. That's a life annuity annuity due starting at age 65 and a half, payable twice a year, unit annuity, so really in 2 installments of 1/2 at the beginning of the year and the middle of the year. Part A is show that Kira's replacement ratio, if she retires at age 64.5, is 50% to the nearest 1%. You should calculate the replacement ratio to the nearest 0.1%. Show that for a retired employee, A double dot upper 2 64.5 is 9.77 to the nearest 0.01. You should calculate the value to the nearest 0.0001. Part C, first part, is show that the actuarial accrued liability at age 63 for Kira's retirement benefits using the projected unit credit method is 433,500 to the nearest 100. You should calculate the value to the nearest 10. And the second part is calculate the normal contribution for the year starting at age 63 for Kira's retirement benefits using the projected unit credit cost method. Of course, normal contribution, normal people call it normal cost, but that's the same concept as normal cost. Let's calculate Kira's replacement ratio if she retires at age 64.5. The benefit payable at retirement at age 64.5 is the product of the accrual rate, the number of years of service at exit, final 1-year salary, and benefit reduction factor. The final 1-year salary, and note that this is the average salary over the last year of service, not the salary just before retirement, because it's supposed to be over a year. So it's half a year from the previous year because she gets raises at birthday, and then half a year with the higher salary from last year. She retires in the middle of the year. So it's 40,000 times 1.03 to the 28th, really plus 40,000 times 1.03 to the 29th divided by 2, the average of the two salaries. And that's 92,889.86. Therefore, the annual benefit paid upon exit at age 64.5 is the accrual rate of 0.02, 29.5 years of service, the salary that you just calculated. I'm using more digits here because I calculated it as much as I could. I always try to use as many digits as possible. Times the reduction factor of 1 minus 6 times 0.005, and that ends up being approximately 53,160.87. And the replacement ratio is the ratio of the benefit to the final year's salary. You could interpret it as the pension divided by the salary just before retirement, but that's not what the Society of Actuaries was looking for. They wanted to compare to the final year's salary over the whole year, average over the last whole year. And as you can see, it's almost, well, it's very close to 57%. For Part B, using the UDD assumption, we have that A double dot upper 265 is the same, well, it's under uniform distribution assumption. It is equal to alpha of 2 times A double dot 65 minus beta of 2, and alpha of 2 and beta of 2 are given in the illustrative service table, while A double dot 65 is given in the illustrative life table. So we plug those in and we get, as you can see, approximately 9.64. But as you know, I always keep as many digits as I can. A double dot upper 264.5, well, that's equal to 0.5, the first payment, plus discounted over half a year, adjusted for probability of survival, A double dot upper 265. And we can get 0.5 P64.5 from the illustrative life table, noting that it's equal to P64 divided by P64.5, 0.5 survival over the next half a year. And that's 1 minus the probability of dying. And under UDD, 0.5 Q64 is 0.5 times Q64. And all of those values are now in the illustrative life table. We plug them in, we get the value of the probability of survival, which is 0.9901438. So the A double dot upper 264.5 is what we get when we plug all those numbers in, and that is equal to 9.77 to the nearest 0.01. For Part C, let S sub x denote the salary earned between exact ages x and x plus 1, assuming continuous employment during the year. We are calculating the actuarial accrued liability at age 63 for Kira's retirement benefits using the projected unit credit cost method. The portion of the actuarial liability due to retirement at age 63.5 is the probability of departing then, so the probability of retirement, which we can get from the illustrative service table, discounted over half a year, 0.02 for the accrual rate, 28 years of service, salary at 62.5, and then the annuity factor and times the reduction factor. This is 18 months before normal retirement age, and it's 0.005 reduction for each month. And basically the same way for retirement at age 64.5. Note that we use the retirement, the number of retirees applicable for age 64 here and for age 63 before, because we know that people retire in the middle of the year before age 65. At age 65 they just retire exactly at that age, and everybody retires then. That's why the portion of the actuarial liability due to retirement at age 65 is simply the population that is there. Everybody retires. The probability of retirement at once you reach age 65, the probability of retirement is 1, and the probability of retirement, what fraction of the people from age 63 retire at 65 is given by L65 tau divided by L63 tau. Discounted over 2 years, the accrual rate is 0.02, 28 years of service, salary from age 64 times A double dot upper 265. Now you might ask why we're using the salary from age 64, and the answer is because now she retires at exact age 65, so the last year of earnings is whole year of earnings with the salary from age 64. There is no adjusting for half a year in this year and half a year in another year. It's all that age salary. So the total of the three can be written as you see here. And well, the salary for age 62.5, we can calculate this is over the last year of work, so half a year in one age and half a year in another. The same for 63.5, we already calculated that in part A, and 64, it's 29 years of increases. We also know A double dot upper 2 63.5, A double dot upper 2 64.5, and A double dot 65 upper 2. And one of them is given in the problem and the other two were calculated before. Then we have the data from the illustrative service table. So we plug that in. We get the three numbers and we plug them in to get the complete answer, which is 436,531.57. This is 436,500 to the nearest 100. For the normal cost, or normal contribution, as the book calls it. So the crucial insight for the way the current textbook for the exam phrases it is that it really effectively makes you work with what I like to call the recursive reserve formula. Actuarial liability or accrued liability is like the reserve and normal cost is like the premium. And what is the main recursive reserve formula? It's the reserve plus the premium accumulated with interest pays for the reserve next year for those who survive, and for any kind of benefits that are paid out where the reserve is released. For life insurance, that's deaths, but for retirement system, it's the people who exit the system in some way, retire, quit the job, die, and so on. So this is a form of this recursive formula. Normal cost is discounted with interest and probability of survival, reserve or accrued liability at the end of the year, minus the reserve at the beginning of the year, plus the expected present value of costs of benefits for mid-year's exits, because all exits occur in mid-year other than retirement, which once people retire, there's no normal cost. Because for age 65, at age 65, everybody retires immediately. See, after age 65, you would not calculate any normal cost here. So we already calculated the accrued liability, actuarial liability, at time 0 for this year. And then we need to figure out the accrued liability. We basically use the same method of calculation as before, but before we had 0.02 times 28, so that was the common factor, and that was 0.56 that showed up in the formula. Now it's 29 years of service. And otherwise, the calculation for retirees in the middle of the year, and then the retiree is retiring at age 65. And this is, once we do the calculation, it's 410,753.91. The expected present value of the cost of benefits for mid-year's exit, well, they have 28.5 years of service, accrual rate of 0.02, and then the probability of departure is retirement in the middle of the year. Salary for them applicable for that last year before that middle of the year, the annuity factor, and after reduction multiplied by the reduction factor of 0.91. all of these we can just plug in and calculate. Therefore, normal cost is 410,753.91 plus 40,654.84 minus 436,531.57, and that ends up being 14,877.17. Now, in this calculation above, we need to deal with the two cases separately, because for the life still in force at age 64, the contribution must fund one full year of accrual, increasing from 28 to 29 years of service, while for the lives who exit at age 63.5, we only add 1/2 of a year of additional accrual, 28 to 28.5. Well, that's the end of this problem. Please remember that this is copyrighted material. The problem comes from Society of Actuaries. The solution is mine. The problem is reproduced with permission. Good luck in your studies and good luck on the test.